And you'll admit Dunwoody. Okay, so you may or may not be familiar with Oscar Pistorius. This is a case back in about 2014 or so. Oscar Pistorius was this chap called the Blade Runner, and he was accused of having murdered his wife, girlfriend, in a fit of rage. And half of the South African population was opposed to him. They thought he was guilty. The other half felt that he wasn't, and there's no, he was being put against. So was he guilty or was he not? And the trial swung backwards and forwards. Was he going to be given off, or was he not? And this poses a problem. Just as with this second character, the second lot of pictures we got over here, a chap called Taina Pora, you may have recognized this. About 20 years ago, he was accused of rape and murder of a woman called Susan Burdett. But about 3 years ago, he was released because it was found that the prosecution was faulty. So there are lots of cases in the law of situations where people have been found guilty of something they haven't done, or they've been and put in jail, or they've been released and for something they did do. O.J. Simpson was a classic case in point with that situation. So we have this situation over here. Is the person guilty or not guilty? Should they go to prison or should they not go to prison? Now, if they're guilty and they go to prison, that's fine. We're happy with that. If they're not guilty and they don't go to prison, we're also happy with that. However, there are issues. If the person is not guilty and they go to prison, that's a problem. And if they're guilty and they don't go to prison, that's a problem. And so we have this situation of the morality of this. Now, when we come to dealing with hypothesis testing and things like that, there are possible errors that we're going to make in the same sort of way. These two over here, putting a not guilty person in prison or not putting a guilty person in prison, are the types of errors that we might make when we work with samples. And they are called type 1 and type 2 errors. So it all deals with whether we accept or reject the null hypothesis and how we react to it. So I'm going to take a diagram over here. Say we've got a set of samples, and we come along here. In this situation, we've got a sample, this one over here, the mean is about there. Second sample, so this is sample 1. Second sample has a mean that's round about over here. This is the acceptance rejection zone. This is another sample, the mean is over here. We'll call this sample 3. This is sample 4, where the mean is actually outside of the acceptance zone. It's in the rejection zone. This is sample 5. Again, the mean is in the acceptance zone. And this is sample 6. Again, the mean is in the acceptance zone. Now, in fact, if we look at these means that we've got over here, it would appear that the mean should be roundabout over there and not over here as indicated in the middle of the graph. In which case, this sample that we've got over here, the one that we rejected because it is in the rejection zone, that one actually may have been all right, given that we were working with a faulty mean at the start over here. And this is what we refer to as a type 1 error. And a type 1 error is when we go and reject a true hypothesis. The second type is down here. So we've got the mean situated over here. If we take a look at our samples now, this one, the mean is over here, and it seems to be in the rejection zone. This one also appears to be in the rejection zone, as does this one, as does this one, as does this one. Whereas this one is in the acceptance zone. Now, if we take a look at these samples that we got out of there, it would appear that the mean should actually be most probably more like this. And then it may well be that this one is actually, the one that we accepted might actually be in the rejection zone of the new mean. However, we have accepted it because it was in the original faulty mean. This is a type 2 error. And a type 2 error is when you accept a false hypothesis. And what you're going to do when you're working with these errors is to work out the probability of falling into one of these zones. So just to recap then, when we take the null hypothesis, it could either be true or it could be false. The decision that we make could either be true or it could be false. There are four possible outcomes. We could either reject the null hypothesis when it's false, or we could accept the null hypothesis when it's true, or we could accept the null hypothesis. Sorry, the second one was reject the null hypothesis when it's really true, or we could accept the null hypothesis when it's really true. Or we could accept the null hypothesis when it's really false. And this is in fact the situation. So if we accept a false hypothesis, that's referred to as a type 2 error. If we reject a true hypothesis, that is a type 1 error. Of the two, this one is the more dangerous. This one, it's faulty, but it's not a major. So if I go and put into prison someone that is not guilty, it's unfortunate for that person, but it doesn't actually damage the rest of society. Whereas if over here I go and release someone that is guilty, that is a potential risk to society. And that's why I say this type 2 is a more problematic one for society. For civil rights activists, type 1 would be a significant one. Now, in order to work out these two types of errors, the first, for the type 1, that's quite simple. The probability of a type 1 error is simply going to be determined by the significance level of the test. So it might say, right, we're going to do the hypothesis testing at 5%, then the probability of a type 1 error will be at 5%. The type 2 error is more tricky, is a little bit more difficult to sort out. And so I'm going to take an example through this and work through this with you. Now, in the textbook itself, they just launched straight into the work with errors with binomial problems. They don't have many problems with normal problems. So I have gone and put onto the grammar page some examples that I want you to work through once you've seen this practice over here. So let's take a look at this example. Right, I don't know why that's still circled. Peter claims that the average score for the final exam is 60%. You gathered a sample of 57 papers and calculated the average to be 57% with a standard deviation of 12%. We need to test your sample at the 1% significance level. So here is the situation. We've got a normal distribution, the results for the test, and here we've got the mean, which Peter claims to be 60%. We've got a sample that is of size 51, and we've got a test statistic at 57%. We've got a standard deviation of that test statistic at 12%. So what we want to work out now is where's the acceptance and rejection zone for this. So the null hypothesis is going to be that the mean is at 60. The alternate hypothesis is that the mean is going to be not at 60, but less than 60. The sample that I've got seems to indicate that it's going to be less than 60. Not 57, less than 60. So this is going to be a one-tailed test. And I need to figure out where is my rejection zone going to be. So it's going to be somewhere over here. And we're going to be looking less than that. So in order to find my critical value, it's going to be 60 minus the Z-score for a 1% significance level. Okay, I haven't put that down, have I? Let's just take that out. So we've got the significance level. This is that in red. We have the significance level at 1%. That means our Z-score is going to be at 2.326. I get that from the table. So if I want to find my critical value, where the acceptance zone and the rejection zone start, it's going to be 60 minus 2.326 times by 12 over root 51. And when I crunch all that together, I come up with a value of 56.01. I think it is 56.09 rather, sorry. So therefore, I'm going to take a look at the values I've got over here. This value here is 56.09. This is my rejection zone. This part on this side is my acceptance zone. The score that I've got, 57%, is greater than 56.09, and so therefore I'm going to accept the null hypothesis. So that's just a standard hypothesis test. Now, the probability of a type 1 error is going to be at the significance level of the test. So the probability of type 1 error is simply going to be 1%. And if you're asked to get the type 1 error, especially with a normal distribution, then it's going to be a straightforward situation. However, the type 2 error is slightly different. And you'll recognize a type 2 error because they will give you the real value of the mean. So Mr. Liu actually knows that the exam average was really 58%, not the 60% that Peter claimed it was at the start. What is the probability of making a type 2 error? Now, best way that I can explain this is to have some diagrams again. So there's my first situation. We had the mean at 16, and we had the rejection zone being somewhere over here at 56.09. So this part here was my acceptance zone. But now, in fact, according to Mr. Liu, the diagram shouldn't look like this. It should have actually looked like this, because the mean was actually over here at 58%. Now, we accepted everything above 56. Whereas with a 1% significance level, that critical value should have been further across to the left. So the error that we've gone and done is we've gone and accepted this value as being our critical value, even though it should have been slightly different. So what we want to do when we want to work out the probability of making a type 2 error is we're going to say, what is the probability that the marks that we're dealing with are greater than 56.09, given that the mean is equal to 58, not 60, 58. So I'm now looking at this black curve, and I'm wanting to find what is the probability of being in this acceptance zone of the red curve. That will give you the probability of accepting a false hypothesis. So we're now going to look at the probability that Z is going to be greater than 56.09 minus 58 over 12 root of 51. And if we crunch all of that together, we come up with a situation of looking at a value of this minus 0.655. And if we convert that into a percentage by looking at our table, we'll come up with a value of 0.7438. So therefore, there's a 74.38% chance of a type 2 error. So the key thing here is you want to find out where the acceptance zone exists for your false hypothesis. And then for the type 2 error, you're going to look for the probability of being in that acceptance zone, but you're going to work with a new value for your mean. And that's what the probability of a type 2 error is going to involve. So what I'd like you to work on is you can go and read this through. It's in chapter 1. I say the examples that they deal with there are all examples with a binomial situation. And the binomial situation is a little bit more complicated than the normal situation. So that's why I want you to go and do the questions that you find on the GrammarNet page. Let me just check and see if I've got the GrammarNet page up. On here. Yeah, I have. So on the GrammarNet page, you'll see further down on the book over here, I've got a page from an old textbook that we've used. Try working through those. I will, if I get the chance a little bit later today, post some of the answers up there so that you can check what's happening with it. This is possibly I think the trickier part of the course, which is partly why we leave it to the end. The questions, if you've had a look at past papers, you will see that quite a lot of the time the calculation is done right at the end of a question. So they'll normally lead you through and you'll do a hypothesis test, and then you'll find a type 1 error, and then they'll ask you to find the type 2 errors. So there are multiple levels that you work through here before you actually get to the final part. But that's what I'd like you to work on today. All right, any questions about what I've spoken about there? This is a recording, so once I've finished this, I will save it and put it onto the grammar page as well, so you can always refer back to it as you are working through things. Okay, if there are no further questions, I'll just do a quick screen chat. Just want to take a quick screenshot of this. Okay, right, guys, if you don't have any further questions, I don't have any further things to say to you. So have a work on that, and I'll see you again. I won't see you again tomorrow because I'm going to be in school working with the tutorials. So I will set work for you, and I'll have some videos for you to watch with that as well. Okay, see you later, guys.
Thanks, sir.
Thank you,
Cheers,
sir.
Yeah,
Thank you.
bye.
Thank you.
Cheers. Goodbye.